Hey guys, welcome back to the LearnAPChem series here at LearnAP. In this video, we're going to go over factor labeling in Sig Figs. So we're going to talk about how to factor labeling with squares and cubes, what is a Sig Fig, rules for Sig Fig operations, the general rule of 3 Sig Figs. As usual, leave a comment if you're confused or have questions. You can also ask in the weekly live streams we do every Sunday from 5 to 6 p.m. Eastern, where we answer your questions about AP Chem. So without further ado, we'll get started. Alright, so let's talk about factor labeling now. Factor labeling is used to convert between units. So to factor label, you're going to need to multiply by a conversion factor. So for example, there's 100 centimeters per 1 meter. Now factor labeling is very fundamental to AP Chemistry, so make sure you understand this before moving on to other stuff. So I'll start by walking you through an example problem. How many furlongs are in 20,330 inches, given that there's 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile, and 9 furlongs per mile? So I find the best way to start these is to just write this base number that you're given over 1. So 20,330, and then always write the unit, IN, over 1. Now, here I've laid it out very simply. We're going to go from inches to feet, feet to yards, yards to miles, and then miles to furlongs. It's not always going to be set up that easy, but for now, let's just proceed as it were. So to get this to feet, what I want to do is write 1 foot over 12 inches. And now what we can do is we can cross cancel, but we're cross canceling the units. So we're crossing out inches here. And if we carried out this operation, we would see that we'd be left with feet. So I can continue to do this. 3 feet equals 1 yard. Again, cross cancel, I'm left with yards if I complete this operation. And I'll just continue doing this until we get to what the question is asking. So again, cross canceling yards leaves us with miles, but we want furlongs. And here, if I wrote this as normal, 1 mile, 9 furlongs, I'd see that I can't cross cancel. But I can just write this the other way around, so with furlongs on the top. And now I can cross cancel, and I'm left with this. So whatever this is going to yield us furlongs. If you're curious, this is 2.57 furlongs. Just rounding that. So that's the basis of how to factor label. Alright, now let's try factor labeling using squares. How many square centimeters are in a square meter, knowing that 1 meter equals 100 centimeters? So if I set this up as normal, I have square meter is our starting, so I'll write 1 meter squared over 1, and I know from our conversion factor that 1 meter equals 100 centimeters. Well, here we have a problem because I can't cross cancel meter and square meters. So in this case, all you have to do is just square your conversion factor. And so what I'd be left with would be this. 10,000 centimeters squared equals 1 meter squared. So I get that in 1 square meter, there's 10,000 square centimeters. I can do the same thing for cubes. I would just cube this rather than square it. Alright, let's talk about Sig Figs now. Sig Fig is shorthand for significant figure, which are numbers that are carried over to the next operation. And these arise because some measurements are more accurate than others. So if I had a very, very precise measurement, and I use that measurement to convert to something else, I'd want to keep the fact that that was very, very precise, and thus use a lot of Sig Figs. So how are Sig Figs denoted, and what qualifies as a Sig Fig? A number that is non-zero is always significant. So 7 is a sig fig here in 70. A zero between two non-zero numbers are also always significant. So in 201, 0 is a sig fig. Now a 0 written after the decimal point can be either. If we have what are called trailing zeros, meaning that there's no zeros coming after them, or I'm sorry, no numbers coming after them, this would be considered significant. So these are trailing zeros because I have no numbers coming after these zeros, and these are significant. On the other hand, if we have zeros to the right of the decimal point that are not trailing, these would not be considered significant because they are not trailing. They have a significant figure after them. But keep in mind that a zero between any two non-zero numbers is significant. So here, these zeros would be significant. Now you can denote a zero as significant by using a bar over the last significant zero, if that's the last digit, or a decimal point, if it is the last digit. So here, if I had the number 100, and I wanted to denote that this zero was significant, I would just put a bar over it. If I wanted to denote that this one was also significant, I could put a bar over it, or I could just write a period. Alright, so let's use some practice now. How many sig figs does each number have? So pause your video, unpause when you think you found the solution. Alright, so for this first one you should have gotten 3, second one 4, third one 2, fourth one 5, and the fifth one 3. If you got that, feel free to fast forward, but otherwise pause and I'll explain these to you. So this first one, we have 2 sig figs, which are non-zero, and we have a 0 between 2 sig figs. So that gives us 3 significant figures, because this 0 here is significant. Here we have 2 sig figs, 1 and 8, and then 2 trailing zeros, which are always significant. So that's how we get 4. This third one's a little tricky. This 0 is trailing and therefore significant, as well as this 1 because it's non-zero. But these zeros right here are not trailing, so they are not significant. So that's how we get 2. 98.002 is the same principle as 1. We have significant numbers here and here, and we have 2 zeros between them. So all numbers on this number are significant. For 5, this 0 is denoting this bar over the 0 is denoting that this 0 is significant. However, the 0 to the right of it is not, so that's how we get 3. Again, if you have any questions, be sure to leave a comment and I'll help you guys out. Alright, so let's talk about math using sig figs. When multiplying or dividing, do the operation and then round using the same number of sig figs as the number with the least number of sig figs. So here in 5 times 5, we have 1 sig fig each. And so what we're going to get if we do that is we're going to get 25, which has 2 sig figs. So we need to round this to have 1, which is going to give us 30. Similarly, if we had 5.0 times 5, we're again going to get 25, but this 5 only has 1 sig fig, so our answer needs to also have 1 sig fig. When adding and subtracting, do the operation and then round using the number of decimal places as the number with the least number of decimal places. So here, 5.982 minus 3.21 is going to give us 2.77, because here we have 2 decimal places, here we have 3, so we need to round our answer to 2 decimal places. When we're using conversion factors, keep the number of sig figs from your original number. Conversion factors are considered exact unless otherwise specified, so they would have like an infinite amount of sig figs if you want to think about it that way. Alright, let's do a quick practice problem, so pause the video, unpause when you're ready. Alright, so for this first one you should have gotten 5,000. The second one you should have gotten 89.9. 0.041. The third one you should have gotten 0.020, and the fourth 18. So how did I get these? Let me explain. So this first one, we're just going to do 80 times 60. I'm going to get 4,800. And now we can see that 80 has 1 sig fig, and so does 60, but 48 has 2. So we need to round this to 1, and we're going to get 5,000. Now the second one, again, I'm just going to be adding 32.654 and 56.3867. Now if I do that operation, I'm going to end up with 89.0407. And we can see here that this last one has 4 sig figs, or 4 decimal places, and our third one has only 3, so our answer needs to have 3 decimal places as well. So we're going to round that to 89.041. Alright, for the third one, again, we're just going to multiply 0.001 times 20, and I'm going to end up with 0.02, and we can see here that both of these have 2 sig figs, and we can see that 20 has 2 because of the dot after it. So I have to add the 0 afterwards. So I'll make that just a little more clear, 0.020. It would not be correct without that last 0. This last one, we just simply divide. We end up with 18, 2.0, and 36 have 2 sig figs, so we are good with that. So it's just 18. Alright, so let's talk about the rule of 3 sig figs now. Most of the time on the multiple choice section of the AP test, you'll be given 3 sig figs. So when in doubt on the multiple choice section, round to 3 sig figs if you're not sure. Alright, so that brings me to today's challenge problem. Now before I talk about that, maybe the tomato soup on the right's making you a little hungry. So if you so want, pause your video, get something from the fridge, unpause when you got something. I'll wait. You got something? Okay, great. So let's talk about the challenge problem. The tomato soup on the right was measured at a volume of 36.0 milliliters. How many stones of tomato soup are in the bowl? So your answer should contain the proper amount of sig figs. The density of the tomato soup is 2 grams per liter, and there are 6,350 grams in a stone. There are 1,000 milliliters in 1 liter. As usual, the solution to this problem is on our website, LearnAPChem. I'll also include a direct link in the description. If you found this video helpful, please like and be sure to subscribe for future content. Like us on Facebook and follow us on Twitter for updates about our new videos and live streams, which we do every Sunday from 5 to 6 p.m. Eastern, where we answer your questions about AP Chem. Links for that will also be in the description. If you're looking for other resources to help you learn AP Chem, be sure to check out our resource recommendation video. I'll put a link for that in the description as well. Finally, leave a comment if you're still confused about anything, or also any other comments on the video in general. Maybe you want to comment what you got from the fridge. Other than that, I want to thank you guys for watching, and I'll see you in the next video.